I'll kick off. Greetings, folks. My name is Martin Farley. I work currently at UCL. I run Leaf. It's my last day at UCL, so I put Green Lab Associates, and I should mention I'm moving over to the UKRI sustainability team, which is kind of exciting. But anyways, I wanted to actually, that discussion that we just had is a very good prompt for what I'm about to mention. So I thought I'd start with a little quiz because I'm going to talk about wet labs, environmental sustainability, and I know there's a coffee break coming soon. So just to keep you on your toes, energy used to cost a major London research institution around £15 million per annum. How much do you think it's going to cost them this year? And I used to work at King's. I work at UCL's, and this is not too far off. Anybody want to? Well, let's say 2 years ago, before the energy prices increased. Yeah, it's just very, very, very close, actually. Yeah, yeah. So yeah, the answer is D. What percentage of that comes or goes towards our research institutes? Sorry, I should say, sorry, our labs, our lab facilities, our science buildings. At least at UCL, I could say that figure is around half. So it's a good chunk of our energy is going, and that's just focused on scopes 1 and 2. This is, you really, yeah, by bringing this up, this is the total CO2 emissions evaluated for 2 major European institutions. So we have here UCL and then University of Copenhagen, and you can see that energy consumption for the overall pie is kind of low, and it's exactly what Alex just mentioned there, which is that our emissions are very high associated with scope 3. Now, you mentioned that figure around 100 million tons or megatons associated with clinical research that came out of Sustainable Healthcare Coalition. You're entirely right. The way that we evaluate this is largely through economic factors. We can measure our travel data accurately. We have a harder time measuring the impact of the materials that we buy because there's an embodied carbon associated. We can see how much we spend on these things, but we don't always know the emissions associated with them. So these figures might change in time as we change our evaluation methods, but at least right now we can see that emissions associated with the purchase of materials is quite high. And actually from UCL, we did try to estimate it, and around 50% of our carbon emissions, it was 48 or so, were still coming from our science facilities. So it's really high impact area for us. University of Copenhagen, they went around slightly different methodology, but it was interesting to see that it was slightly comparable. They didn't divide it by labs per se. They looked at some other categories. So yes, we have life cycle assessments, and that's kind of how we understand the embodied carbon of the stuff that we buy. And it's not just for wet labs, it's for other areas as well. And we're here talking about computing. One of the questions I have, and I'd actually be curious about, is about the balance between energy consumption of servers and the embodied carbon of replacing them. It's something I don't understand, and it's a question I get asked about sometimes. But we have analogous comparisons within life sciences around the storage of samples and the freezers required for it, or the facilities that we use to store these samples. And I think we can make a comparison between the data that servers store and the samples that we store within our freezers. So we have good data on our energy and sometimes our spend in IT, and you're going to hear about that. But we're doing life cycle assessments to better understand the rest of the pie, because right now, as mentioned, it's based on economic factors. I'm going to plug a paper that we just got out because it was looking at this, and it just came out a week or 2 ago, and it was looking at essentially life cycle assessments of lab consumables to try to better understand what is the impact of somebody working in a lab. To try to do a case study on this, and we found that actually, a typical wet lab, there's a small case study in there, and we tried to evaluate, and it totally changes depending on what you're doing. But your consumables associated with some wet lab work might be up to half a ton of carbon per annum. Keeping in mind that personal quotas of carbon, you should ideally, if we're all going to 1.5 or 2 degrees Celsius, be consuming around 4.5 tons per person per annum, which is just a context for how much that half a ton is. It's a good chunk of carbon going towards wet lab consumables. Now, just to make this slightly fun, again, I know this is maybe not fun, but I wanted to give you a quiz question again. So this is from our study, and it was thinking about how we can take those learnings and put them into practical applications to reduce our carbon associated with our work. So if you've worked in a life science lab or tissue culturing, you're going to be working with these different plates for tissue culturing, and you can get polystyrene or polypropylene plates. And there's different carbon associated with them, but you can buy both, and there are some different applications. Does anybody, you can throw up a hand. If not, I'll tell you the answer. I've got all the answers. It's anybody want to guess? Well, the deep well plate will have the most CO2, and it's a good chunk more, actually. I should have put up the figures, but they're in the paper. Okay, this is getting a little bit messy, but what is the order in terms of CO2 emissions magnitude? So which of these has the most emissions and the least emissions associated with them? And these are common things that we find within a wet lab environment. I'll give you a second to just have a look, have a think. If anybody want to shout what they think is the most? Yeah, very good, yes. Anybody want to give a guess at the least? I need to remember, actually. There's no, it doesn't, I can't see the prompt to the next slide. Okay, well, I'll give you the answers anyways, in case you're curious. And this is, you can see there the emissions associated, very high in disposable gallons. Over COVID, we had shortages of these gallons. So some of the animal facilities we worked with had to move to reusable gallons. And actually, that was a transition that was acceptable for the most part. So without risks of further lab animal allergens, which was a positive case study. Any chemists in the room want to guess the emissions associated with some different solvents? Really making this fun, I'm sure. I know this is about computing. Okay, I'll give you some of the answers. Actually, I was kind of surprised by this. Methanol was the lowest, and the ethanol, which we use quite in large volumes in labs to decontaminate. If you spray ethanol all the time, has quite a high carbon impact associated. Now, this is focused on green chemistry, and by the way, I just want to mention there are resources out there on green chemistry. They are some of the ones that I've put up here, and particular credit to the Chem 21 guide around green solvents. But I guess the message I want to get across is more research is needed in this space. We don't have the answers to everything around how to do net zero wet lab work, and it's great to see that there are a lot of initiatives around life science labs, but we have a lot of work still to do in this space. And whether it's we talk about freezer temperatures or the life cycle assessments of things, trying to understand where the full impacts are, the hotspots are, and how to better improve this. We're still looking at this, and while we need to do more research on to better understand it, we need to still enable the action that we can now. And I won't mention the timeline of things. Actually, Charlotte described that really well, I think. So the actions that we can do now, well, I think that we need standards in this space. And I'm slightly biased, but I like the analogy with health and safety, which is that there's a reason that we all follow health and safety, but sustainability essentially is voluntary right now. So if you want to be sustainable, it's an optional choice that's up to you. But we accept health and safety. We accept it as synonymous with the work that we do within in science. The way I kind of got started on this effort around LEAF was actually coming to the Wellcome Trust, and a long time ago now, 7 years ago I think, and I came and I asked Wellcome about putting conditions in grants around environmental sustainability, and they came back with a really good piece of feedback, which was, we need to make things comparable. We can't just put things into grants. It needs to be able to fit into a system, and so that was very helpful feedback and part of the motivation to go start LEAF, which is the framework that I'd set up at UCL, and it's a sustainable labs framework looking at the environmental sustainability of wet labs. And I won't go too much into it, but you can see the resources online for it, and I'd encourage you to check it out. It does have some things on IT and computing, I will say. It's not as extensive as it can be, but we do have a few things, and it really touches on that common ground between samples and data. So, trying to get folks to consider, particularly if they're storing large amounts of data, clearing it out and not copying it too many times and having clear out days. This is just something on Leaf, just to say it's grown a lot, and I'm leaving it. There's 4,300 users from 2,850 labs in 16 countries. And it was great that the Medical Research Council had a target of its own facilities achieving gold by 2025. So it's really encouraging, and we've been working with the NTDC, which is great because there's this really common ground between technical staff and trying to advance environmental sustainability. Now, I mentioned research quality. I wanted to leave it on some, I guess, more expansive thoughts on wet lab environmental sustainability, and this is why we had some actions around research quality. Now, this is from Nature, and they were looking at the reproducibility of research and highlighting that a lot of researchers agreed that there was a reproducibility crisis, but it wasn't in their lab. And actually, when you think about it, irreproducible science in some ways is the least sustainable. Leaf and some of the actions that we take and what we talk about is about addressing, freezer temperatures and how we operate in the lab and chemicals and solvents and what we purchase. But there is an element of the purpose of the science we do and the accessibility of it. And there's this common ground, I think, between good lab practice and reproducible science, and that, in their same survey, they were showing that a lot of the ways that we improve reproducibility is through good lab practice. So that's in part why we put some actions around research quality within Leaf, was to really highlight that common ground. Sometimes reproducibility is associated with folks that are trying to manipulate data. It's for the most part, it's not that. It's just our ability to good lab practice and sharing our results in transparent ways. I have this final quiz question, which is just an annoying one, but it's a fun one. I don't have the answer to it, but I like to ask it, which is, of all the research that gets conducted and published or shared widely, how much of it is accessible and reproducible? And it's interesting to think about all we put into science and trying to get the most out of it. And maybe some simple steps around good lab practice can help us really get the most out of it long term. And I guess one last area I just want to mention is what we expect in return from science itself. The type of science that we actually do. And this is, I took this angle from UNESCO. UNESCO does this really interesting report on the state of science. They do it every 5 to 6 years. There's one coming out in not too long. And their most recent report looked at the context of climate change and science and how it is being adapted to address climate change. And they pointed out that essentially there's maybe an imbalance between the type of science we're doing and the needs of the moment. And they were saying that essentially, there was 147,000 articles on AI in 2019 and just 2,500 on carbon capture. And we heard from Charlotte that we don't know how to essentially capture all the carbon that we need right now to achieve our targets. So I thought it was interesting that UNESCO was looking at the directions of science. So I guess I wanted to leave on that message, which is that we think about the sustainability of science, we think about wet labs, but we can also think about how the research is done, the accessibility of it, the communication of it, the good practice of it, and also the directions that we go with our research in the future. So in case you're interested, there's a lot of resources. I'd encourage you to check out some of the Green Lab programs from some of the institutions that I've put up there. We've got Leaf resources, and then we have a Green Lab network around the UK, which is called LEAN, if you're interested in joining. It's just folks that are sharing good practice around the environmental sustainability of labs, and I put the website up there. And then I just wanted to also say around Green Labs, in case you're actually in the environment or your institutions, people ask what to do to get started. You can start with Leaf, but also you can just get folks together and talk about this stuff. And give a space for coming together. And actually, that's one of the best things out of any program around sustainable labs, is just bringing people together and getting them to share good practice amongst themselves. And I hope we've been able to do that with some of the programs. So, I think that's actually it for myself. Where is this topic going? Well, I think technical staff are going to be incredibly important to this in the future. And that's part of what we found when we were piloting Leaf, is actually, technicians are really at the forefront of managing lab spaces. I'm focused on sustainable lab stuff, but I think there's going to be increasing centralization of services, and carbon impacts will be better understood, because we don't understand the full carbon impact of some of the things we do. We're going to see more guidance and standards on best practice, and that includes for other spaces, like we haven't spoke about infrastructure or the building of lab spaces, the refurbishment of lab spaces, because actually that's really important as well. And I think we'll see increasing transparency for manufacturers, hopefully. But of course, we need to combine our language and the way that we engage them to work with them in that space. And finally, one day, I think, at least right now it's voluntary, but I could imagine one day it might be like health and safety where it's required. But at least for now, it's going to remain voluntary. So that is it for myself. Thank you very much. And I've put some of the sources up there. So thank you very much.